Thank you very much. So to give a time to introduce modern silicon technology in Wacker side. So yeah, nowadays LED is a hot topic for the lighting application. So also for every LED makers and then also for some silicon makers are focusing on how to develop our product to meet the customer requirement for this rapidly increasing LED market for lighting application. Okay, this is the contents I would like to introduce today. Today, so at first I briefly would like to introduce Wacker Silicone, and then so next one I explain the silicon market for the LED industries, and then so third one is I would like to explain why silicon is selected for the optimal encapsulation material for LED lighting, and also so what is the trend for the silicon development for LED lighting, and finally so I would like to explain what is the Wacker silicon solution for LED industries. Okay, Wacker is almost 100 years old company. We based on the Germany, and then so last year we got the sales 4.63 billion in last year, and then employees over than 16,000, and still increasing for the industry increasing for our customer. Okay, this is our business field. Wacker business division is divided by the industries. So if you are interested in any others like automotive, electronics, solar, and energy, and semiconductors. So we are very close to the customer, so with a silicon solution to support the customer application. Okay, we have 24 production sites globally, and then so with over 100 sales office, we are very closely support customers with the silicon solution and others, polymers and then other chemical solutions. In Korea, so we had a head office. So it was founded in 1995. So it was increased rapidly. Now we have a silicon R&D center. So this silicon R&D center in Korea is focusing on the electronics and photonics like LED, and also we are supporting some medical and T&D applications. So in Jincheon plant, we are producing silicon sealant, and then so recently we made clean room production line in Jincheon plant, so to support the electronics and optoelectronics, photonics, and every materials which is related to the electronics application. Okay, also in India, we have a sales office and then also technical centers. So together with Mr. Singh and so Mr. Tiwari and the technical manager, Mr. Park, we are supporting in Mumbai, in India, so with our technical center in India. Okay, next one, so I would like to explain about the silicon market situation and forecast for LED lighting industries. As you see, so silicon market for LED industries is increasing so rapidly. So until 2015 year, so we are expecting CAGR 15.6% for quantity. It is much higher than other industries. But so as you see, for the total amount for the silicon sales in globally, it just grows 0.5%. So that means as the LED industry is increasing, so the demand for the request from the customer for the cost down is very, very tough. So that is the reason why silicon material price is decreasing, as you see. So this is a very nice news for the LED makers, but the silicon suppliers, it is not very tough time. So, but the total sales anyway is increasing because so LED lighting application industry is growing very fast. Okay, now there is no argument about why silicone is the best material for LED lighting application, because from a time, so as you know, so epoxy was the main material for encapsulating LED material. But the problem of epoxy is very weak for the summer aging. So as time goes on, the epoxy material just change its color transparent to yellow. So also nowadays LED light is mainly used for the electronics, and then it is installed in the PCB circuit board. In that case, so LED has to tolerate the SMT process. SMT process is installing LED chips on the PCB substrate. In that case, all LED chips have to tolerate around 260 degrees Celsius temperature for over 10 minutes. In that case, epoxy material cannot survive with such a kind of very tough processing condition. Only LED silicone material can pass. So, Wacker, so we just selected these two parts. So this one is LED. This is a conventional LED structure. So there is a LED semiconductor chip on side, and then there is a gold wire with frame and plastic packages. Sometimes the ceramic is used for the high power LED. But this encapsulation part and LED lens part has to be made with a very transparent material. So silicone is the position for this lens and encapsulation part. Okay, when we talking about the LED light for general light application, that is white LED. There are so various LEDs in the market, but only white LED can be used for the lighting because it makes white light. Normally, LED chip, LED semiconductor chips gives a blue light. So as Mr. Choi explained, so blue light has to be converted to white light. So that is the reason why customers have to mix the post-pour or some coating or sometimes some alternate post-pour layer is needed to convert this blue light to the yellow light. So together with the yellow light, the blue light together with the yellow light, you can make the white light. Sometimes customer using red or sometimes green, but the yellow phosphor is the main material to make white LED. And then, so for the general lighting application and also for the backlight unit application for LCD backlight unit, so every LCD display has a backlight to make the white color light. So we divided this kind of big three categories. So one is warm white, the other one is cool white, and then last one is backlight unit application. For each application, the customer needs each color temperature. So for warm white, around 3,000 Kelvin color temperature is needed, and then cool white, so you need around 6,000 Kelvin is needed. So as you see, as Mr. Choi explained, white color is not one. There are a lot of white colors in this coordination. So customers asked about which coordination is needed for their applications, and then so LED makers are making their LED chips to meet the customer requested color temperature. So silicone. So why silicone is selected for the main material for LED encapsulation and optical materials? So I can say, thermal stability. There is no other material who can be more strong for the thermal stability than silicone material. Silicone material is the optimum material at present. So that is the main reason why silicone is selected. For a time when the customers used the epoxy material, when they started to change the epoxy material to silicone material, they always ask us about the electronical stability and so purity and optical transparency and so sometimes water repellency. But because epoxy material sometimes have some trouble with the electrical or some purity problem, but when they started to use the silicone material, there is no argument nowadays. No discussion about this stability because basically silicone material is quite nice material for the electronics business. So sometimes it is used for the semiconductor, sometimes it's transmission and distribution application. These four properties are basic properties. So and together with that, this thermal stability. So silicone is selected for the LED industry, the main material. Okay, this is a silicone manufacturing process. From the sand, we are extracting silicone metal, and then so it is synthesized to chlorosilane, and then it is polymeride. After that, all together, we are making silicone mixture for the LED application. And also, as you see, everything is produced in clean condition because defect ratio in customer side is very, very important. Sometimes, if the customers can decrease the defect ratio, they are willing to pay more, more price to get the pure silicone because defect ratio is the main factor to increase LED cost. And also, so this is the curing process of silicone material. No byproduct, no shrinkage, no reverse reaction, and then so you can control the speed of the curing, the speed of the curing time. And then so this is the reason why silicone is. If it is shrinkage, and then if it makes some byproduct, I think LED industry is very similar with the semiconductor industries. So semiconductor industry, if some material shrink and then if it makes some byproducts, it is directly related with the defect. So main reason, stress of the LED customer is, as I mentioned before, so decreasing defect ratio as much as possible. So that is the reason why silicone material is the addition type hydrosilylation silicone is selected for the LED application. Okay, there are two big groups for the silicone material which is used in LED lighting. So first one is metal-based silicone material, and the other one is panel-based silicone material. But unfortunately, they have their own advantages and disadvantages. Metal-based silicone material, it has very good, nice thermal stability, but in case of panel-based material, it is relatively weak thermal stability than some metal-based material. But efficiency point of view, because of the refractive index, because postpone material has reflective index 2.5 normally. So that's the reason why you can make higher efficiency with the panel-based material than normal refractive index material. So metal-based, higher thermal stability, little bit less efficiency. Panel-based material, so high efficiency but lower thermal stability is the characteristics of this kind of materials. Okay, so nowadays, even silicone is selected for the best material for the LED lighting material industry, but still, there is some customer needs to increase the LED lighting performance. So that is, so I would like to explain some things about that. This is one institute report. That institute is supported by the Korean government, and then they made this kind of report to show the strategy roadmap for LED industry in Korea. Among them, so we selected these three things: more light extraction for efficiency, and more reliability, and then cost down. So nowadays, silicon makers in Korea and also in globally are focusing on this kind of target to achieve this kind of trend of LED industry in globally. First one is light extraction efficiency, because as you see, phosphor material has refractive index 2.5, but silicon material maximum refractive index is just 1.53. That gap makes the loss because of the in between the different refractive index, light reflect, and then that gives a loss of light efficiency. So target is increasing and increasing, but the problem is there is some limitation of silicon chemistry. Because of that, we are still struggling to increase the refractive index, but I think 1.6 or 1.7 would be a maximum technical limitation of silicon material. And also panel-based silicon material. So if it is decomposed by heat, this panel linked each other, and after that cross-linked the panel material absorb some UV range light. That means it changed its color from transparent to yellow. So that is the main reason why panel-based silicon material cannot be used for the general lighting. As you know, so nowadays LED power is increasing and increasing. So for a time, LED is just used for the remote corner or backlight unit, but the more power means more heat generation. So that is the reason why panel material cannot be used for the LED lighting application. I don't know. So in future, how much power will be increased for the LED industry, but the heat would be the main problem for the aging of LED light. And the other one nowadays, this is a hot topic for the LED lighting. For a time, so LED lighting customers just use the gold substrate to reflect the light from the bottom to the top. So, but in the case, there is no reason to worry about the sulfur gas from the outside. As you see, sulfur gas is the very problem. So in the very polluted area, sometimes, even not only it's a polluted area, but also the normal life. In your kitchen, so if you cook some meat in your kitchen, normally they generate sulfur gas. Also, human body generates some sulfur gas from our body to the outside. So that means all around the air in Earth is surrounded with sulfur gas. But the problem, customers changed the reflector from gold to the silver because of the cost reason. I heard, if LED customer uses a gold substrate, the price of a LED package would be increased 3 times and 4 times because gold is much expensive material than silver material. But the disadvantage of silver is, as you know, so if you have a silver ring, it is easily changed its color to brown because of sulfur gas. So that happens also in the LED. So if it is exposed to the air has some sulfur gas, and then sulfur gas can penetrate to the LED chip inside, and then it decomposes the silver substrate, and its color would be changed to the brown, and then color temperature would be increased, and then light efficiency would be also decreased dramatically. That is a very big issue in LED lighting application. That is the reason also that because of that is the reason why silicon makers and also LED package makers are developing Yeah, so we are focusing more on the sulfur gas blocking performance of LED chips. Yeah, now, yeah, for this kind of reason, yeah, so silicon material is not perfect material for the sulfur gas blocking, but yeah, in case of a panel-based material, its performance for the sulfur gas blocking is better than metal-based material. But as I mentioned, there is some dilemma. Panel-based is good for the sulfur gas blocking, but very bad for the heat aging. But metal-based, very nice for the heat aging, but it is bad for the sulfur gas blocking. So, yeah, target of the silicon maker is combining such a kind of advantage together, to increase LED performance, LED lighting performance in LED industries. Okay, so I would like to explain about what is the silicon development trend for LED lighting. First one, so we separated this kind of properties for the silicon performance. Yeah, one is refractive index, the other one is sulfur gas blocking, heat stability, and price. So, as you see, in case of a panel-based silicon material, yeah, our main target is increasing thermal stability and then price. Panel-based silicon material is 3 times more expensive than normal refractive index material. Yeah, that is the main reason why LED makers cannot decrease the cost for the LED production. And also to decrease panel-based silicon material price, also the silicon suppliers also focusing on and then tried our best to decrease the production cost of panel-based material. And then in case of normal refractive index material, metal-based, main hard issue is the sulfur gas blocking performance. So, because normal refractive index material price is more attractive than the panel-based material, so main target for the technology is focusing on the sulfur gas blocking performance. Okay, so now I would like to explain what is the Wacker silicon solution for the LED industries. Okay, this is our silicon portfolio for the LED lighting in solution, LED lighting manufacturing. So, first one is lens, second one is encapsulation, third one is coating. But I always explain to customer, so there is no silicon material which is only specialized for this application. They are all transparent silicon material. So main target and then main homework in LED manufacturer side, how to decrease the production cost to make cheaper solution for their end customers. But it is highly related with the processing condition. In my customer side, sometimes they are complaining about the silicon material price, but the problem for them at present is they have to dispose of sometimes over 2 times or high, so 60% or sometimes over 70%, they have to dispose of silicon material to make just 30% product. And also the cycle time to make some product is very slow. So main target of the LED makers who is using silicon is productivity and cycle time. So according to your selection, so sometimes dispensing, sometimes injection molding, sometimes coating. If you wanted to select best processing in your production line, these materials can be suggested by the Wacker or other silicone suppliers, sales managers. So that means you have to focus on more about your processing with the silicone material. After that, so you have to select proper silicone for your processing condition. This one is mainly designed for the silicone encapsulation. Nowadays, for general lighting application, nobody uses a single chip solution because that is more expensive solution to make lighting. For more time, silicone LED makers, LED lighting makers, to make 20 watts, they simply just assemble 1 watt LED, multiply 20 LEDs, which is 1 watt LED power. But nowadays, they just make 20 watts LED multi-chips at once with the encapsulation with the silicone. So already the trend is already changed. So A71 is designed for such a kind of multi-chip LED encapsulation. A72 is designed for the single chip solution. But the single chip solution mainly used for the backlight unit application. And A68, it is also designed for the single chip solution, but the special thing about this grade is it is mixed with silicon. So nowadays every LED customers are mixing phosphor material to make a white color light. In that case, because phosphor material density is around 2.5, silicon material is lighter, just around 1.1. That means if you mix phosphor material, as time goes on, phosphor material will go down and the sediment is to the bottom. In the case, you cannot make uniform LED package. So I heard from my customer, and the customer asked us what the LED chip light does. Blah blah luminance and blah blah X coordination, Y coordination, color temperature like this. And then lighting makers are making LED light, so according to the customer request. After that, they are making this range LED lighting, but the customer just wants this range LED lighting product. In that case, you have to select LED packages, so LED lighting, only this range, and then other range you have to store in your warehouse. There is very big loss of LED lighting. There is a reason why LED lighting customers would like to make uniform phosphor dispersed LED chips in their production line. So this product is designed for such a kind of request. For 2 days, over 2 days, normally 1 day is needed. So for 2 days, there is no phosphor sedimentation, so that means you can make uniform LED lighting from the bottom of the cartridge to the top of the cartridge. And also this is mainly designed for to produce LED lens. So there is separated by the viscosity nowadays. So you can use these 4 processing: stream molding, compression molding, transfer molding, injection molding to make LED lens or other optical device. But nowadays the trend is more goes to the injection molding because of the productivity. So if you wanted to make 1,000 or 2,000 lens a day, stream molding is enough. But if you want to more 10,000 or 100,000, you cannot make LED lens with the stream molding process. So that is the reason why lens customers are moving to the injection molding process. In that case, 7600 high viscosity material would be the solution for the injection molding. So opposite side, 400 is can be applied with the stream mold. But nowadays the trend for the LED lens makers are going to the injection molding process because of the incredible productivity of this process. Other one, some customers would like to remove some process. Like semiconductor application, less production step means less cost. If you need 5 or 6 steps to make some LED lighting, if your competitor just using 3 or 4 steps, you cannot compete with your competitors. So that is the reason always LED lighting makers would like to decrease the step for the LED lighting production. And this grade is a little UV curing grade, so they do not need the molding process to make a dome-shaped LED lens. They just dispense and then cure with normally like this. If you drop one water on the top of the glass, it would make some dome shape. After that, if you fix it with the UV light, that dome shape will be maintained. After that, you do not need some mold process to make lens. That is the reason why this grade is developed. So this is also commercialized and then used for such a kind of non-molding process LED lens application for lighting application. And then also nowadays some customers already moved to the next generation. Nowadays they think, okay, why we need LED chips to make LED lighting? They would like to remove LED chip, so LED package to make LED light. So in that case, coating and then highly reflective. So this one is needed. So just a customer just put the semiconductor on the top of the PCB directly, and then gold wiring, and then they just coat with this material together with polymer material. That's all. And then in this case, you do not need LED packages or some kind of SMT process. Sometimes some other assembly process you do not need it. After that, you can decrease production cost dramatically. These some accessory material for the LED lighting material. As you see, summer heat generation from the LED chip is very hard issue. That is the reason why this kind of thermal interface material is used to that heat move out from the heat sink, from the LED to the heat sink, and then finally you can decrease the temperature of LED with this kind of thermal interface material. And next one, Semicostal 810 UV ODH material. It is mainly used for the assembly, the secondary lens. Normally silicone ODH material is a heat curing process is needed, but some customers do not want to apply heat because after all assembly, some parts are very weak for the heat. They do not want to apply the heat. In that case, this material would be the best solution to adhere secondary lens on the top of PCB board. And 984 is developed to encapsulate and protect the lid frame. And then this primer G800K. Former time for primer solution. Customer asked about, I like this. I need adhesion on the glass. I need adhesion on the metal. I need adhesion on the plastic. In that case, we suggest the other the different primers for customer need. But nowadays, LED is some kind of combination of materials. For the LED lighting, sometimes you need adhesion on glass, sometimes plastic, sometimes metal, sometimes silver. In that case, this primer can give you a multiple functional solution to make adhesion on every substrate. And finally, this is SLM775L7. It is still in the development stage, But as I explained before, some customers think, why I need LED chips for the LED lighting? So in the case, they just coat with the white silicone on the bottom of the LED light, printed circuit board PCB, and then just put LED chip on the top of PCB, gold wiring, and encapsulation, and that's all. So with this kind of new material, you can decrease 3 or 4 steps to make LED lighting. So I think it would be a next generation LED lighting structure in future. Okay, summary. LED lighting. I don't need to explain more, because everybody knows LED lighting industry will be increased. And then silicone elastomer. So there is also no argue about the silicone elastomer is the best material for the LED lighting application. And then, so there is some limitation of silicone. So there is a reason why every silicone supplier is focusing on the developing silicone elastomers to achieve the customer request. And then Wacker, Wacker is investing, so a lot of money and then human resource for this kind of success of lighting industry. Okay, so for appendix, so you should know, this is clean room production line in Korea, like this. So as I mentioned before, so like other display and then semiconductor industries, defect ratio is most important thing, because defect ratio is directly and very, very related with the cost increase for your production line. So as an example, in Korea, if defect ratio is over than 10%, you cannot make any money. So you have to decrease as much as possible. So you have to decrease the defect ratio less than 5%. So that means, in case of silicon case, the particles and ions, impurities, is the main reason to make a defect in the LED chips. So there's a reason why Wacker made this kind of clean room production in Korea to make silicon material particle free. With this process, so actually, in Korea, so customers could decrease the defect ratio, and also so they can get more profit from the LED manufacturing. Okay, thank you very much for your attention, and so thank you.